Hello there! This video is going to show you how to run a single sample t-test and a paired samples t-test in Microsoft Excel to recreate a result section of an actual study that was published in 2016 looking at how social affiliation in infants can be developed through familiar lullabies. So the authors of this article really suggest that melodies and lullabies are shared within social groups. So if you are an infant and you're familiar with a certain lullaby that your social group has taught you, if you meet another adult who shares that lullaby with you, that you may, as an infant, feel more social connectedness to them because you may infer that that new person is a member of your social group. So you'll see that this is something that you can't just do a survey and ask infants about, right? So this is an experimental study where they manipulated different lullabies and they measured the attention span and how long those infants paid attention to those adults. So you can read this on your own. We're going to look at the actual article for a minute before we jump into the analyses. And it's worth mentioning that this data set and this article was provided through Open Stats Lab through Trinity University, which is a really awesome resource for stats professors like me. All right, so let's take a look at the article real quick before we jump in. So here you will see some things that I highlighted. So in the method, and we're just going to focus on experiment 1, they had parents come to the lab and they had to learn a song. And they were randomly learning one or the other song. There's 2 different lullabies that are used in the study. And they instructed the parents to sing the song to the baby as much as they would like. And then after 1 to 2 weeks of song exposure, the infants returned to the lab for a selective attention test. So they taught the parents the song. You can read more about the method where they actually made sure that they had pitch and the right tone and that they were practicing and that they were actually doing what they were supposed to do. So you look here, there's a little section on statistical power, and I only bring this up because we've talked about type 2 error in class. And remember, type 2 error is when you don't get a significant effect, and chances are it's because you didn't have a sufficient sample size or you didn't have sufficient power to detect that effect. So you'll see that before they did the study, they did a power analysis to find out they needed at least 32 participants in the study to have the power to detect a positive selective attention effect. So they're trying to avoid type 2 error there. So here you will see that at the first lab visit, each parent was randomly assigned to learn one or other song. And that was mentioned up here, right? They learned how to sing those songs to their babies. Then after the first lab visit, the parents were emailed daily with a survey to determine the approximate number of times each infant heard the song each day. So they're trying to control for any kind of variation in how many times the parents sang that lullaby that was supposed to become familiar. Then they came back to the lab a second time and they tested the infant's attention to 2 novel individuals who sang the song that was either familiar or the song that was unfamiliar. So you'll see that this explains that process, but they have a nice illustration of it up here. So there's 4 trials. In the first trial, they looked at 2 friendly faces smiling at them side by side. Then in the second trial, they heard somebody sing either the familiar or the unfamiliar lullaby. And then in the third trial, they saw the other woman sing either the familiar or the unfamiliar lullaby, the one that wasn't sang by the first one. So if this first one sang the familiar lullaby, then the second one, the lady in blue, sang the unfamiliar lullaby. Then they repeated the baseline trial in the fourth trial, where they just showed the 2 women smiling at the infant. And what the main hypothesis of this study was is that whoever sang the familiar lullaby in trial 2 or 3 is who the infant would pay more attention to in trial 4. And you'll see we're going to actually do 4 analyses here to not only see if there's a difference between how long the infant stared at which lady in the 4th trial, but to also control for their differences in attention at baseline. So that's explained here, but the pictures make it a lot easier. And what they did was they recorded the infant's gaze for each of the 4 trials with a hidden high definition camera, and they coded it frame by frame. So they were able to really tell where the infant was looking and for how long. So we're going to use Excel to recreate this results section. And notice the APA style here. So if you're ever asked to, recreate a results section APA style, this is a really good template to use, and you'll see how the output aligns with this write-up right here. So let's jump back into the assignment. So first, we want to show that the infant's looking behavior did not differ from chance during the baseline trial. So we want to make sure that before they saw any of the women sing any songs, there was no attentional bias prior to hearing the unfamiliar others. So we're going to do a one sample t-test where we're going to look at the baseline proportion of the gaze to the singer, the eventual singer of the lullaby that they are familiar with, and we're going to compare that to chance, which is just 50% or 0.5, to see if they spent more time looking at the person singing the familiar song at baseline compared to chance. So you want to make sure that they didn't already prefer one singer to the other before that they saw them sing, right? So making sure that they didn't already prefer one before they were even introduced to which one was going to sing the familiar lullaby. So I'll walk you through how to do that in Excel. So let's pop into here. So we are going to be focusing on, you can see this is the explanation of all these values here. You'll see in this first column, that's the ID of all of the participants. And then here you'll see some numbers. So this first column is the proportion of time that the infant viewed the video of the unfamiliar person who would eventually sing the familiar lullaby. So you'll see these are all under 1. So 40 for this one, like 43.7% of the time that they stared at the two pictures of the ladies that they looked at. If you look at So we're looking at this, right? So what percentage of the time did the infant stare at the woman who would eventually sing the lullaby? This one is the familiarization, the gaze familiar. So how long the infant spent looking at the video of the person singing the familiar lullaby. So for instance, if the lady in the red shirt was singing the familiar lullaby, that next column represents how long the infant stared at her. Then we look at this column here. This is how long they stared at the unfamiliar lullaby singer. So that would be, for instance, if the lady in the blue shirt was singing the lullaby they'd never heard, how long they stared at her. And then finally, this is the proportion of the gaze to the singer. So what proportion of the time the infant viewed the woman who sang the familiar lullaby. So after they stared at him, she sang the familiar lullaby. She did not. Now, what proportion of the time, what percentage of the time did the infant spend looking at the woman who sang the familiar lullaby? And then this is just those differences in proportions. All right. So now let's go ahead and do the analysis. So first we have to create a chance column. So we're going to right click here on C, hit insert, and just type in chance. And chance is going to be 0.5. Now I'm just going to drag that down, click on it, right? Go to the bottom right corner, see the little plus sign, click and drag down, and it should fill it in. If that doesn't work, you can also click on it, Control C to copy, or click copy. Highlight all these values, hit Control and V to paste, or just hit paste right here. So now we're going to go to the Data Analysis tab. If you do not have it, I have it, Data Analysis. You need to install it. So you want to click on File, go to Options, go to Add-ins, Analysis Toolpack, click Go, make sure Analysis Toolpack is selected, and then you want to click OK right there. So now when you go to the Data tab, you're going to see that the Data Analysis option is available. So let's go ahead and click that. And this is basically going to help you get an output that shows you all the values that you've been calculating by hand all this time. So you go down, we're going to choose t-test to sample assuming unequal variances and click OK. Our variable 1 range, let's just highlight the baseline, proportion to singer, all of that. And then for variable 2, we're just going to highlight our chance values, which is just 0.5 across the board. The hypothesized mean difference, you can just leave that blank. Click labels. That tells Excel that the first thing that you highlighted up here was a label, not a number. You can leave your alpha at 0.05. And now let's put this in a new worksheet, and let's call this baseline versus chance. And then click OK. Now before we look at this, let's go ahead and right click. Make sure it's all highlighted. If it's not already, you can just highlight it. Right click, Format Cells, Number, 3 decimal places, hit OK. Then go up to Home, Format, Auto Fit Column Width. Now we can see everything, which is great. So let's just take a look at this real quick and kind of figure out what all these values indicate. So first of all, you'll see this says mean. Here is the mean proportion baseline of how long the infants stared at the woman who was eventually going to sing the familiar lullaby. So on average, they looked at the woman who would eventually sing the familiar lullaby about 52% of the time, which at face value doesn't seem to be that much difference from chance, or 50% of the time. This is your variance. Now, variance is hard to interpret, so I'm going to turn this into a standard deviation. So I'm going to write SD equals, and I'm going to put my standard deviation right here. And remember, the standard deviation is the square root of the variance. So I can just type in equals SQ, look for squirt there, double click it, click your variance, hit enter, and your standard deviation is 0.176, or really 177 if you round. All right, observations. There were 32 infants in the study. The hypothesized mean difference default is no difference at all. This is your degrees of freedom. If you were looking up your critical value in the t-table, this is where you would look. Remember, n minus 1, and n is number of observations here. We have our t statistic. So that is the t observed, that if we did all the math in step 3, that's what we would have come up with. Then we have our one-tailed critical value and p-value, and our two-tailed critical value and p-value. We are going to stick with a two-tailed test because those are harder to achieve there. So there's our two-tailed test. And let me just double check that's what they did in the study as well. Let me look at the data. So their t-value was 0.067. Yep, that looks good. And let's see, their p-value was 0.51. So let's just double check that. Yep, they totally did a two-tailed test, as they should have. So just to show you how this aligns with the article really quickly, I'm going to do a little split screen action here. So you can see that the mean was 0.521. That's reported right here. The standard deviation that we just computed is 0.177. That's reported right here. Then you can see in APA style, you put T, degrees of freedom in parentheses, that's this 31, equals what T observed actually was, which is right here, 0.674, rounded to 0.67, comma, P equals 0.51, that's this P right here, and I'll explain what that tells you here in just a minute. And so you see all those values have been recreated. Now let's enlarge this and kind of break this down even more. So, when we have done this in the past with our manual calculations in our tables, we are going to base our assumptions on the critical value, right? So one way that you can know whether or not there's a significant difference here is you can compare your t statistic to your t critical, which is right here doing a two-tailed test. So if we drew this in the traditional way, you would see this. And right here, because it's a two-tailed test, we'd have negative 2.04 and positive 2.04. And any t observed that falls here or here would result in rejecting the null, saying we have a significant finding. Well, this 0.674 is like here. It's just not good enough, right? Now, also, and an even actually better way to determine whether or not you have significant findings is to look at your p-value. So that's this right here. So in this case, this tells you, P tells you the probability that results are due to random chance, or in other words, a fluke. Well, remember, if alpha level is 0.05, then that means we are willing to only accept a 5% chance that your results are due to random chance. Well, in this case, this is basically saying there is a 50.5% chance that the results are due to random chance or a fluke. That's way more than 5%, right? It's pretty likely that this tiny little difference here is just a fluke. It's not due to the infant actually spending significantly more time staring at the woman who is eventually going to sing the lullaby. So an easy way to think about this beyond the concepts is if P is low, reject the hoe, right? Remember, hoe is the abbreviation for the null hypothesis. So if P is less than your alpha level, you can reject the null and say that you have significant findings. But if P is greater than alpha, and let's do less than or equal to here, if P is greater than alpha, then you fail to reject the null and you have non-significant findings. Now, in this case, we're actually really glad that there's no significant difference because we don't want the infant to be staring at the woman who's eventually going to sing the lullaby more before the experiment even takes place and the woman sings the lullaby. So this is good news for us. So real quick, let's take a look at this in the assignment. All right. So let's go ahead and copy and paste our output. So now those notes have magically disappeared. Control C to copy, or you can click copy, put them in, see right here, paste the output below, click right here. You can hit paste if you want, or Control V to paste. This looks good. So now what is the value for the t statistic? That's your t observed, right? That's this guy right here. What's the critical value for the t-test? Well, remember, we're focusing on the two-tailed value here. So just add that. I'm giving you the answers right now. What is the p-value for this test, and explain what that tells you. So if you forgot what my explanation was for that, go back and rewatch that section of the video, but there's your p. Then which decisions should the researcher make, and how do you know based on t-crit and the p-value? So I just went over that as well. Make sure when you answer that, you are very specific about, t observed is within the critical region set by this critical value, and the p is low, it's less than the alpha level, so we know that there's a low probability that results are just due to random chance. Or sorry, the p is high, so we know there's a high probability that results are just due to chance. So that's why we would also fail to reject the null, right? P is greater than alpha. All right, now we want to demonstrate that infants attended equally to the two singers during the familiarization trials. So remember, they looked at, and we can look at the article again. They watched, for instance, this lady sing the familiar lullaby, and then second after that, they watched this lady sing the unfamiliar lullaby, and they just wanted to see if there's a difference in how long they stared at the screen when those women were singing individually. So now we're going to pop in to our Excel sheet, and we are going to compare these two. So during the familiarization phase, how long did they stare at the lady who was singing the familiar lullaby? And during the familiarization phase, how long did they stare at the lady that was singing the unfamiliar lullaby? So to do this, we are going to do a paired samples t-test in Excel. So we're going to click Data, Data Analysis, Paired to sample for means. Click OK. Variable 1 range, we're just going to select this first one. Again, the familiarization phase, how long they stared at the familiar lullaby. And then for variable 2, click here, highlight all this good stuff. Make sure labels is selected because the first thing we selected was the label for each group. Then we want to do a new worksheet, and let's put fam phase, fam versus unfam. All right, let's click OK. And yet again, right click, format cells, number, 3 decimal places out, click OK. Then we're going to go to Home, Format, Auto Fit Column Width. Nice. So now let's look at these values. They look similar to what we had before. We still have the mean for each group. So on average, they spent 15.59 seconds staring at the lady who sang the familiar song. And then they spend 15.309 seconds staring at the lady who sang the unfamiliar song. Then we've got our variances here, but we can compute our standard deviations. And let's just right click, hit insert. And let's just write SD for standard deviation and just calculate that right here in this table. So click enter, squirt, SQ, double click the squirt, click the variance. Check this out, it should work if I just click and then drag this over. Totally worked. It just copied that formula, right? Square root for now C6 instead of B6 like here. That was lovely. Then we've got our observations. There's 32 infants. This is a Pearson correlation. Don't worry about that just yet. We'll go over correlation in a later chapter. Here's your degrees of freedom, 32 minus 1. Here's your T observed that you would get in step 3 if you calculated it. And again, we are going to do a two-tailed test here. So we're looking at these values for our p-value. The probability that results are just due to a fluke, right? The probability that the results, the difference between how long they stared at the lady singing the familiar lullaby and how long they stared at the lady singing the unfamiliar lullaby, the probability that that difference was just due to random chance. So that's what this is. Then this is your T critical, right? So if you drew this out, you would be able to see that your T stat would not fall in this critical region, right? 0.282 is not greater than 2.04 or less than negative 2.04. And your P is not low. The hoe cannot be rejected, right? There's a 78% chance that this difference is just a fluke right here. So let's go ahead and see how that aligns with our article. So let's pop this over here and let's look at the article real quick. So if we look at the results, if we scroll down, we are looking at this right here. So we'll see that infants attended highly and equally to the two singers during the familiarization trials, right? Here's our mean for the singer of familiar. There it is. There it is. Oop. All right, this one's standard deviation. There it is, if you round it to 5.07. Then looking towards the unfamiliar singer, there's your mean, 15.3, and there's your standard deviation of 5.10. And then we look at our t-test results. There's our t observed right there, and our p-value of 0.78 right there. Neat. So yet again, you're going to copy this, Control C, paste it into your Word document right here under number 2. You can hit paste or Control V. And then you're going to answer the questions that I just pretty much gave you the answers to just a little bit ago. If you need to rewind, go for it. Be sure to be specific in your explanation here and specific in your explanation here about this actual data, not just general definitions of things. Okay, now we're ready to see if they stared at, in the last trial, let's remind you of what that kind of looked like. In the last trial, let's assume that the red lady, not the red lady, but the lady in the red shirt sang the familiar lullaby. We're going to see if they stared at her in this fourth trial longer than 50% or longer than would be expected due to chance. So yet again, we're going to do a one sample t-test in Excel and compare it to chance. So let's do it. And we are going to go back to our Excel assignment 2 data. And we're going to go ahead and right click, insert, and we're going to add chance here. So chance. Okay, and again, that's going to be 0.5. And you can just click and drag down with the little plus sign, and it just 0.5s it out. So now let's go ahead and go to data, data analysis, two sample assuming unequal variances. Click OK. This time we are going to highlight the test proportion gaze to singer. So what percentage of the time did they look at the lady who sang them the familiar lullaby versus, I guess we could just use that chance as well, but I like to make things more complicated apparently. Let's select this chance right here for the second variable. Okay. Make sure labels is selected, alpha 0.05. Now we're going to have a new worksheet that's called Fam versus chance. Click OK. Again, right click, format cells, number, 3 decimal places. OK. Home, format, auto fit column width. There you go. You're going to see similar stuff to what you saw before, right? You look here, you can see here is the mean or the average proportion that they stared at that last phase where they saw the 2 pictures side by side and the women were just smiling. What proportion did they stare at the woman who sang the familiar lullaby? Well, on average, about 59% of that time was spent looking at the familiar lullaby singer. Here's your variance again. If you want to do your standard deviation, I'm just going to do it over here this time. SD equals, do the squirt, equals squirt, square root, double click of the variance. There's your standard deviation. 32 infants. Hypothesized mean difference default is always 0. Degrees of freedom, n minus 1 is 31. Here's your t statistic if you calculate it in step 3. And again, we're going to focus on two-tailed findings. So here we can see that there is if we turn this into a percentage, 0.6% chance that this difference is just a fluke. Right? Remember, if the P is low, reject the ho. If the P is less than your alpha level, you reject the null and say you have a significant difference. And here, I'm thinking that's the case, right? So this is telling us it's very unlikely that this is just due to a fluke, that the difference in how long they stared at the person who sang the familiar lullaby is different just due to chance. Here's your T critical, and that kind of mimics the decision that you would make with the P value, right? P is low, reject the ho. Well, guess what? Your T observed exceeds your T critical. That would also lead you to reject the null hypothesis. So now let's kind of look at this side by side. Boop. And let's just see how we just recreated a legit results section from a study. So we look here. Okay. At test, however, the infants selectively attended to the now silent singer of the song with the familiar melody, and the proportion of the time during which they looked toward her was greater than chance, significantly greater, in fact. Here's your mean of 0.593. Here's your standard deviation over here of 0.179. And then you'll also see that we have our test statistic, T, degrees of freedom 31, equals 2.96, and our p-value equals 0.006. Now let me show you how to get Cohen's d here. So this is your d statistic for the one sample t-test. So remember, Cohen's d equals the mean, let's not do that, mean minus mu, just giving you your formula here, divided by the standard deviation. This is like a way to type it without symbols because I don't want to have to use symbols right now. So to do that, I'm going to do equals, parentheses, this mean minus our chance mean, close it in parentheses, slash for divided by, click my standard deviation, and looky there, we got 0.52 Cohen's d. Now you can look at your chart in the formula sheet to determine if this is a small, medium, or large effect, because I believe you're going to be asked about that in your assignment. All right, so now we know that after they saw the woman sing the familiar lullaby, they stared at her significantly longer than you would expect to see just due to chance when they showed the two women side by side. All right, so now we are going to not just compare how long the infants stared at the woman who sang the familiar lullaby at the end of the study to what we'd expect to see due to chance. We are going to compare how long, assuming that the lady in the red shirt sang the familiar lullaby during the second or third phase, we're going to compare how long the infants stared at her in the fourth trial to how long they stared at her the first time they saw her before she saw the lullaby. So before we compared how long she stared at her in the fourth trial to chance, now we're comparing how long the infants stared at her the fourth trial to how long they stared at her at the beginning. So we're really controlling for kind of their interest in her before she even sang the lullaby. So let's jump into Excel, and we are basically going to be using the proportion, what percentage of the time did they stare at her initially, to what percentage of the time did they stare at her after they already saw her sing the lullaby. So we're going to go to Insert. Oh, no, we're not. Data, Data Analysis. We're going to select a t-test paired sample to sample means because we are doing a repeated measures test, right? We measured them before and we measured them after they sang the lullaby. Click OK. So we're going to start by highlighting the test proportion gaze to singer. There we go. And then for variable 2, we're going to highlight the baseline proportion of how long they stared at the eventual singer. We've got our new worksheet. We can call it familiar versus baseline. So it's fam versus baseline. Click OK. Right click, format cells, number, 3 decimal places. Go up to the Home tab, format, auto fit the column width so we can see everything. Now here you see that 5.593 again, right? Because that's how long, or the proportion they stared at them in the final trial. But now we're comparing that to how long they stared at them on average at the beginning, which is that 5.21 that we looked at earlier. So that's our means. We've got our variances. Let's go ahead and right click, insert, SD equals, and just put our standard deviations right in there. Equals our squirt of the variance. And then you can just copy that formula over with the little plus sign, drag it over, or you can click and drag over and do fill right. There's our standard deviations. We have 32 observations still. Don't worry about the correlation. Degrees of freedom is still 31. Our T statistic, our T observed in step 3 is 2.416. And now let's talk about what that means a little bit because that's pretty important in this case. So I'm going to write it out for you. So remember, when we look at the T statistic, you're comparing how much bigger is the actual difference you observed in means. To the difference in means expected due to random chance. So if you think about how fractions work, if you had like 10 divided by 2, your numerator is 5 times larger than your denominator. Well, in this case, your numerator is 2.416 times larger than your denominator. So the actual difference in the proportion of time that the infant spent looking at the singer before and after she sang the familiar lullaby is 2.416 times larger than the difference you would have expected to see here just due to random chance, just due to sampling error, just due to a fluke. So your actual difference is 2.416 times larger than the difference you'd expect to see due to chance. So if you think about that, it makes sense now that our P is low, right? Our P is less than our alpha level of 0.05. So we can reject that null hypothesis, say there is a significant difference here. And we also know that because this 2.416 exceeds this critical region of negative or positive 2.040. Remember here, right, this is telling us now too that there's only a 2.2% chance that this difference that we see here is a fluke and just due to random chance and not due to a true effect of the familiar lullaby being sang. So now let's go ahead and copy and paste our output, Control C to copy, into our Word document, Control V to paste. And let's also quickly look at how this compares to what we saw in the journal article. And just note that I've given you everything you need in the video to answer all these questions except for Cohen's D, and we'll look at that here in a minute. So let's look at our Excel. Let's bring it over here, and then let's look here. So you can see that not only was the proportion of time during which they looked towards her greater than chance, but it was also greater than baseline. Now here you'll see that 2.42, that 0.022, and then Cohen's D we'll get really quickly. I'll show you how to get that in just a second. And then we look here at the different mean and standard deviation. Those are not here. I will show you how they got that. They actually looked at the difference scores to get that value. So let's go ahead and go over here, back to the data. So right here, you'll see these are the difference in looking. So this is basically just taking the test phase, the proportion, minus the baseline phase, what proportion they stared at the lady who sang the lullaby. So we're going to get the mean and standard deviation from these, and I'm just going to do those over here. So I'm going to put mean equals SD equals for standard deviation, and do this in Excel, not by hand, equals AV, double click the word average, then just highlight all these different scores. Bam. Okay. Then our standard deviation equals STD. Make sure you select the one that's STDEV, standard deviation for the sample. So S, double click that. Then highlight. I'm going to just hold down Shift, click the bottom one. It highlights everything in between. Hit Enter. Now you will see where that mean and that standard deviation came from right there. So now to get Cohen's d, we are going, and I'll show you the formula sheet where this is coming from. Where are you, buddy? Right there. So for the two related samples, to get Cohen's d, you take the mean of the different scores divided by the square root of the variance, or in other words, the standard deviation. So let's see what happens when we do that. Equals, remember these are all your different scores, and that's what we got the mean of, divided by the standard deviation of those different scores, and we get 0.43 right there, Cohen's d. So now you have every single thing that you need to complete your Excel assignment. I hope that you feel empowered by Excel and you're excited to learn that these tools are available to you, and you don't have to bust out a calculator when you actually do research and practice with large amounts of data.